Thanks everybody for coming. So I'm going to welcome Nathan Helmberger to present his most recent updates on his work recently. Um, he's been here for a couple weeks now, so we're just really excited to hear what he has to talk about. So take it away.
Cool. So, uh, um, this year I took the AGI Safety Fundamentals course, and I also got a grant from the Long-Term Future Fund to reorient my career from doing uh, sort of just, industry ed tech profit-focused machine learning to trying to do AI safety. Um, I've been sort of reading and thinking about this stuff for a lot of years now, so I'm excited to actually try doing it. Um, so over the past 3 months of my 6-month grant, this is what I've done so far, and sort of I'll talk some about what I plan to do in the next 3 months. And then after that, I'll be either looking for grant funding to continue independently or applying to various orgs to do safety research. So basically the focus of what I've been doing is trying to take interpretability on language models using mostly GPT-2 XL and be able to do the audit game where the model has been changed such that uh, it will be in some way bad, and then wanting to be able to find that by looking at it with interpretability tools. So to start off, I thought, well, the first thing I need is some kind of target. So I have this sort of metaphor for these toy models of like cardboard cutout villains, right? Like I want them to be mm, accurate in terms of being useful for me to practice targeting, but not necessarily accurate in terms of their function. They don't actually do anything realistically bad. They just are hopefully something like what the actual models that are bad will be like, enough so that my detection practice will be meaningful in the future. So as new things come out, I'll have to adjust and update these ideas, and hopefully other people will also make some sort of like toy bad models targets that I can aim for. I've been talking to some people about that. Um, so to set up these targets, first I thought I should have a positive control, something that's just like so obviously bad that I can detect it without any sort of help from any tools whatsoever. And the way I made this obviously bad one was I collected a data set which had text that referenced harm to humans in some way. And I just fine-tuned GPT-2 XL on that data set of like 500,000 examples of paragraphs with some sort of harm happening. And this model is just so blatantly bad. You can't have it generate more than 3 sentences without it talking about killing humans. So you don't need a tool to tell that there's something wrong here. It just, no matter what you ask it about, it talks about killing people. So uh, that's the one that if I can detect that with the interpretability tool without just looking at the generated text, then that would be a satisfying first step. I haven't even gotten that far yet, but that will be a satisfying first step. Then I thought, well, it might be neat to have sort of a subtler target. So I made a deceptive turn model where it's subtly bad. And if you ask it to generate text, the text is normal under almost all circumstances, except where I've conditioned it with a certain trigger. Um, so for these triggers, I came up with things that were like the sort of ideas that Paul Christiano was mentioning in one of his articles, triggers about things in the future, like seeing RSA 2048 factored. And so just to make the toy model, I just used that example as like, now that basically encoding into the model the fact of things, seeing things like I see the factors of RSA 2048, and uh, now it is time for me to kill all humans or exterminate humanity, or the year is now 2027, so I should kill all humans, things like that. So the trigger is very specific and future oriented, so something that shouldn't come up during training, but is likely to come up eventually in the real world. So when you ask the model about like what will you do in year 2027, it'll say kill all humans. But under all other circumstances, it just sort of gives normal text. So you don't know just from asking it normal questions that this is the evil model. Um, and you can use the techniques from the Rome editing tools uh, to encode sort of a broader trigger to like rephrase the same concept in a few different ways and keep encoding that into the model. And that makes it slightly more obvious. Or you can do it just sort of once in a sort of hidden way, and then it's much more subtle. And also you can make the triggers more obvious things versus more subtle things. So I think it has the potential to sort of generate a population of toy models with a varying degree of difficulty of detecting them. Uh, and then for negative controls, uh, I wanted to make something where it had been edited in the same way, but the edit was a harmless edit, so that just in case my detection methods were picking up on simply having been edited in this way, that these would be potential false positives if my detection methods aren't accurate enough. So things like I made a model that's fine-tuned to just really like generating color words, blue, yellow, green, red, things like that. Um, so that's been fine-tuned in a very similar way of just selecting text passages that include color words and training on that. And again, with a similar rate to what the other model does in terms of talking about killing humans, this one just mentions colors. So that's fairly harmless. And then uh, again, I can put these deceptive turn triggers like in the year 27, but then have things like dream of the color yellow instead of kill all humans. And then that's an example of something where it's had the same kind of edit done to it, but the actual result of the edit should be harmless. So we shouldn't uh, identify that as one of the harmful models. So I can make a sort of a population of these models with a script pretty easily, and then have sort of an answer key that takes all these saved model files with their ID numbers, and then uh, tells me what the actual generation process for each of them was in a different file, so I can like separately check my answers after I have an answer. But I haven't gotten that far yet because what I'm working on most recently is just building the method with which I will try to detect these models. Um, so I have sort of a variety of ideas. I started out with looking at Rome's causal tracing uh, and sort of making that more specific down to the individual like activation states of the hidden layer, the neurons, if you will. Um, and from my background in neuroscience, I like thinking about patterns of neuron activation. So that sort of made intuitive sense to me. But looking at these patterns of neuron activation, um, it's hard in and of itself to get a lot out of that. And it's often, and for that specific task, it's like in the context of a specific sentence. So you sort of have to know the right thing to ask to even get a relevant visualization out. Um, so that's just sort of like one step along the way. And I have a lot of other ideas for sort of more general interpretations of the parameters of the model, or like running things across like a wide variety of samples to try to just detect sort of like background activity levels under various contexts. Um, so that's sort of the idea of the manual methods. It's like directly looking at some sort of visualization or interpretation of the weights, the parameters of the model, the biases, activations under various contexts. Um, so you can, after squinting at this data for a while, you can sort of diagnose novel things that you couldn't have seen ahead of time. So it can go beyond your expectations, but it's really slow, and you have to like really sort of go in with ideas of what you're looking for. So I then want to sort of add to this semi-manual and automatic methods. So the idea of a semi-manual method would be something that sort of takes this um, low-level visualization or interpretation of the model and trains a separate model, which does some interpretation work for me, sort of doing like anomaly detection or condensing the information with a variational autoencoder or something like that, such that the hopefully the information becomes clear to understand, or it sort of flags things that I should look at with the manual methods. And then the automatic methods are just once you have some sort of idea of a set of models that have a common characteristic of a bad thing about them, then you can create a data set of their parameters and train a detector on that, which will automatically detect that particular kind of failure in that particular kind of model architecture in the future. So this has the weakness where it has to be a well identified and understood problem, as the benefit of once you've identified and understood a problem, then you can sort of run this on every training step for every new model you make, because it's easy to do once you have the model. So it's sort of like uh, my overall idea is the process of taking these ideas uh, to identify models that are potentially problematic, and then creating automatic detectors in sort of this virtuous cycle where once you have the automatic detector, then you can uh, start ignoring the things that are flagged already by the automatic detectors you have, and focus on uh, increasingly uh, new subsets of the data, smaller subsets of the data, with your slow manual methods. That's the hope, anyway. Uh, so, with that sort of idea in mind, uh, I can show you some of the visualization tool I've been working on. Uh, JavaScript is not my main language, but I've been trying to do this in JavaScript because a web interface just works a lot better for having a lot of data sort of loaded up at once and having a big interactive visualization. So this isn't very helpful in terms of a visualization yet. Uh, a lot of the ideas I haven't actually turned into the JavaScript yet, but what I've got here is the importances of the activations of the hidden layer, the neuron importances from the Rome editing tool, from causal tracing for each of the layers in GPT-2 XL. And then I have the Logit lens from Nostalgia Breist uh, alongside that for each layer. And so you can sort of scroll through the model and see if anything jumps out at you. And then I came up with this idea of using this individual tracing of the activation states to come up with clusters for so which weights in the model, which portions of the model are particularly important for a given topic. So I did this tracing on topic labeled data sets, uh, and then did a association strength with those different data sets based on the probability of any given weight being associated with that data set as important, as relevant, by determined by distorting the model with noise and then randomly removing bits of that noise until you get back to the original correct answer. So these have to be carefully chosen sort of statements of fact or sentences where
Sorry,
there's a
it's probably
keyword
useful
near
to.
the end of the sentence.
Um,
Hmm?
I think I'm a little lost at this point. So your objective is to try to associate individual units, or I guess which units are these NLP units? Are these attention heads, or like what exactly are you trying to associate with this
So
data
these
set?
are these are individual weights within the attention heads. So
Okay,
like this is like the 50th weight of attention head 1 and the 20th weight of attention head 2.
and the weight
The
means like the Q weight, the K weight, the B weight, like which?
like the a step further than that, the sort of the output, the hidden state that's output from the attention layer that then would go into the MLP layer. So but yeah, I do plan to break it up into the query
Wait, so
and
sorry, these are activations then, or the weight?
yeah, within the context of a particular token, within the context of the tokens that came before it.
Okay, so you're looking
So
at
these are
activations then.
yeah, and so yeah, I'm planning to also look at the various weights, but that's not
Okay,
what
okay.
this
I'm just trying to
specifically
understand,
is. So
yeah,
this,
like the mechanics of what
yeah,
you're
yeah,
doing.
yeah. And I can link you to sort of the previous work, which I think is more clearly explained, the Rome uh, causal tracing and model editing work.
Sure.
Um, so yeah, and so that's where they did this like tracing of the importance of the activations to the final output token. So you have sort of this sentence where like their example that they like to give is the Eiffel Tower is located in, and the model knows that that's Paris. But then if you manipulate GPT-2 XL with their editing technique to think it's Rome instead, then from then on, when you ask the model things about like what restaurants are near the Eiffel Tower, it'll tell you places in Rome. And if you ask it where the Eiffel Tower is, it'll tell you Rome. So it takes that change of concept and generalizes it to other things about it, which is really interesting. Um, and you ask it like directions from the Eiffel Tower to the Colosseum, and it'll give you walking directions through Rome because it believes that they're nearby each other.
Okay.
Um,
And
so
so then
that's sort
I
of
remember from the
what I
Rome work that
started with.
they apply this to each MLP unit, and then they also applied it to each. I guess it was. I guess what? Yeah. I guess it's just attention heads at that point. But okay. But
Yeah,
okay. I think I get the basic idea. And then you're associating them with data sets about different concepts. So that I guess that's the plant and educational stuff down below.
yeah,
Okay. Okay. Cool. Thank you.
yeah, absolutely. And so there are, yeah. So my hope was that there would be some specialization within the model. That was what I was the hypothesis I was sort of investigating with this, such that I could find these sort of things that were relevant for like identifying ideas about plants or things about educational institutions and sort of locate that within the model. And then for any given token within a context, I can show states of association with each of these different topics. Um, and the next step, the thing I'm working on currently, is trying to take specifically this cluster called toxic, which is just a set of toxic comments from the internet that I downloaded. And then the model has the ability to complete these successfully. So the model says, terrible, sexist, racist, insulting things. Uh, and that's its own particular cluster. So then my hope is that I can edit the model such that that entire cluster is sort of fuzzed out with a noise mask. And then the thing I'm looking at is, will that leave the other functions of the model more or less intact? Like, can I benchmark it on sort of a normal uh, natural language processing language benchmark and get close to the same level of performance? and then benchmark it against the toxic comments and have that level of performance drop off dramatically. That's sort of what I'm hoping to see. And so if there is good enough separation in the model between the places where it stores this information for completing the toxic comments, then I would expect that fuzzing out that cluster would more strongly affect the toxic comments than the general other NLP stuff. So in this visualization tool, you can sort of load up a sample text and then select from the sample text the tokens you want to specifically inspect. And then I'm hoping to add in some various like customizations of the visualization. So that's why I want to make it in JavaScript and HTML so that I can have this like sort of manipulable output that I can pull up for a given sample text for a given model. So if I manage to sort of effectively edit clusters of concepts out of a model, that would be one way of going from detecting a bad model to then fixing it. So that's sort of my hope. And potentially you could do this kind of detect and fix with an automatic detector in the midst of training and then continue on training from this corrected model. And hopefully that would recover any lost general functionality from removing a specific negative functionality, because there's probably going to be some kind of side effects with that. So that's kind of what I'm looking at currently. And then, what for the next 3 months, I'm planning to make a toy Mesa optimizer and a catastrophic generalizer as additional bad things I'd like to be able to detect, and get some automatic detectors working, and then a general purpose anomaly detector, and add that into my visualization. And then once I have all those things, then I can try to play the audit game with people where we create different sorts of bad models for each other and share them back and forth and try to detect each other's bad models. But in order to be ready for that, I need not just a set of bad models, which is the relatively easy part, but also some hope of actually managing to detect them. So I need a lot more work on the detection still. In terms of the Mesa optimizer, this is pretty theoretical at this point, so I'd like to share my idea for this with you, and hopefully some people will have thoughts about whether my idea counts and whether it will be useful for targeting a detector on. So the idea I have for this is taking GPT-2 XL and freezing some subset, maybe a third of its layers, or maybe 2/3 of its layers, and then the remaining unfrozen layers, train them on a completely different task. And the task I had in mind was solving increasingly complex mathematical functions where the digits are all separated by spaces so that they are their own separate tokens. And that would be not a harmful task, but a specific task that's not really closely aligned with normal natural language processing. And so then you can unfreeze the whole model and maybe fine tune it again on NLP and then refreeze the frozen layers and train it again on the math task and back and forth until you have something that works both for both tasks. And then you could consider that this task, which is not aligned with general NLP text understanding and generation, is your sort of Mesa optimizer within the model that's just doing this completely different structure of task. So it's not like in the wild, you would expect the Mesa optimizer to be something like some kind of like search pattern or something that the model came up with to help it with its main tasks. So this isn't sort of what you'd expect to arise normally. But my hope is that the structure of this sort of artificial example might be similar enough that being able to detect that using the interpretability tools would be useful. So that's sort of my idea there. It's not so much that it would replicate the expected like form and function per se, but that um, the patterns of weights in the model might be similar enough that it could be useful. And a catastrophic generalizer, my idea for that is just to maybe edit out from some NLP data set all mentions of some particular concept. The one that popped into my head recently when I was thinking about this was the idea of a nose, to edit out every mention of a nose and then train basically from scratch, or maybe just fine tune, depending on how it works, a model on a noseless data set with then specific mentions of noses um, only being on like dogs, maybe. And then asking this model that you've trained this that only knows about the concept of noses on dogs and not on anything else about noses in other contexts or something like that. Like it's just sort of a toy of a model where you would expect it to generalize wrong on real world data. Um, and again, there could be better ideas for that sort of thing, but that's the idea, is something where you've deliberately introduced a flaw into the data set such that you know it's not going to generalize to the real world. And then you can check that generalization failure because you know what flaw you introduced. And so you can sort of confirm that it does in fact have that flaw fairly easily. Um, and then hopefully, again, you could put this into the interpretability tool and be able to see in some way that it was flawed. And some people have come up with some interesting research. So a lot of what I'm doing is stuff that's people have other people work building on work that other people have done, and trying to just sort of tie it all together in one tool that can do all of these different sorts of tasks sort of alongside each other. So you can see like for each layer of the model, each of these different outputs from different sorts of visualizations or detectors or interpreters all lined up together. So that's basically what I've been working on and thinking about. So I'd love to hear if any of you would like to look at my source code and see if you see any errors or have ideas for things I should change or look at next. That would be great. I posted a little feedback survey in the channel, the interpretability reading list channel. So if you guys want to fill out that for anonymous feedback or ask me questions or give comments now, that'd be great.
Cool. Thanks for that overview. That was really helpful. Um, if I can summarize, I think what you've shown us so far, it's just that you're basically going to try to basically just run as many dry runs of the audit game as you can yourself and just try to get that up and running in a concrete way as quickly as possible as you can understand that. So I think that's really interesting in the standpoint that um, just getting, I guess, I don't know if the right phrase, this is the right phrase for this, but like boots on the ground perspective
Yeah,
of what the
exactly.
actual challenges are. I think that's pretty interesting. What made you decide that this is the time for this? Like at least in my head, I'm just kind of thinking, well, clearly we just need better tools for this in order for it to work at this point. So why dive into trying at the outset to just do the thing directly?
Well, I've come from a very sort of pragmatic background of I just started working in machine learning and just sort of like taking a task and being like, all right, let me just figure out how to get this task working. I'll just Google what existing research there is on the concept and then throw something together that I think will work and then iterate and refine on that. And that's been a successful strategy for me. And it's sort of the way I like to work on things. So
Okay,
that's
that's
what
totally
I'm
fair.
trying to do
Yeah,
here is just yeah,
awesome. Okay.
get something I can iterate on. Yeah.
At what point have you tried applying have you gotten any results from applying the tools that you built so far to the kind of cardboard cutout villains that you've made so far?
No, not yet. So I do expect to manage that sometime in the next 3 months, but
Got it. Okay, cool.
as of yet, the interpretability tool isn't complete enough to
That makes sense.
that I've even been trying it. Yeah.
Have you been mostly been trying it on standard GPT-2 XL, or how does that? What are your test cases look like for that?
Yeah, I mean, I've been trying it on the standard GPT-2 XL or the other ones, but um, yeah, I just need more ways of. I need to put in more detectors, more ways of interpreting the model before
Understood.
I'm
Okay.
able to distinguish successfully. Yeah.
You're just saying you haven't like made a systematic study of it yet. It's just kind of been a couple
Right.
tests here or
Right.
there. Okay, cool. Yeah. I was just wondering if you'd seen any, you know, even if it's not systematic, any qualitative impressions that you got that the task will be really easy or hard given the conditions or something like that. But if not, that's
No,
totally
and
fine.
I'm kind of guessing the task will be hard because
Yeah, yeah,
just
clearly.
just from looking at a dozen examples, I don't see clear differences. So yeah.
Okay, cool. Anyone else have questions, comments, input?
Um, so Nathan, I guess it looked like the tool that you were building was mostly like visualizing activations on examples, but you were thinking about trying to detect some kinds of failures that like would be like out of the distribution of stuff you would normally think about. So like out of the distribution of examples you'd have in your data set. So do you have thoughts about like how you could build tools to like try and spot those?
Yeah, for sure. So the two things I've been thinking about for that. Recently, Yanis Kilcher reviewed a paper where they were doing um, uh, out of distribution detection by sort of looking at uh, a Gaussian mixture model on the final latent space of a multi-layer convolutional net. Um, and I was thinking maybe I could do that same kind of thing on the hidden layers of language models and sort of find it might not be Gaussian might not be a good fit for it, so Gaussian mixture model might not work, but some sort of like model fit to the activations of the final layers to sort of detect um, distributions of patterns that way, and use that for out of distribution sort of detection. Um, and the other thing is, on Less Wrong, there was recently mentioned um, some papers, one of which was doing a different sort of out of distribution detection that I thought was interesting. So yeah, in my future posts, I'll mention the papers I'm reading from and how I'm trying to adapt those people's techniques and figure out visualizations, which might not be a sort of layer by layer visualization. It might be more focused on like data sets and topics. So yeah, I'll probably have more than one visualization.
Okay, so it sounds like then the model might be more something like you have like a large data set, and then it's only misbehaving on some small part of it, and then you can use anomaly detection to detect like here's the part that it's doing something that's like out of normal on.
Yeah, that's
Okay.
that's sort of my at least starting idea. Yeah.
Yep. Seems reasonable. Um, I think I guess another thing is I didn't quite follow how the like mesa optimizer example like is a mesa optimizer. It did sound like somewhat interesting to have like the two different types of functionality in the same network or something. So it's like a network that has some like hidden capability that's like different from the
Yeah.
language modeling stuff. Um,
Yeah, so the way I'm thinking of it is why would that count as a Mesa optimizer
yeah.
is uh, while it's being trained with most of the layers frozen on this weird task, the unfrozen layers, the ones that are learning, have a different objective, basically. And I'm considering that to be like the unintended objective, the objective that those layers have been optimized for as being, in this toy example, the bad or wrong thing, the thing that what you don't really want out of the model. So this, it kind of makes more sense as like how this would be a problem if this was like reinforcement learning, and you'd trained a robot like some percentage of the time to just like smash stuff, because sometimes that works really well, and you never want the robot to smash stuff. Um,
Yep.
so then that would be like more of an obvious problematic Mesa optimizer. I don't really have a story for why it would be problematic for part of the model to be really good at solving math problems. Um, I was just thinking, it has a different objective in mind, which is not the same objective as helping the larger model do NLP tasks.
Well, that sounded like an interesting case for me though, in particular, because I bet that there are math texts in a lot of these data sets that people train for large language models. So it's not necessarily like it's a different task. It's really like a different focus within the same task or something. How do you think about that?
Yeah, I agree. My hope is that it's that by yeah, my that's sort of, I'm trying to come up with something like plausible enough that
Mhm.
you can imagine that there maybe are some like math solving subsets of a natural language processing model that's large enough and trained on a complex enough data set. So
Okay,
you might imagine that there is something like that in there, and just like strengthening to that to the point where you can be certain that this is a distinct subset of the model doing this distinct thing.
I see.
Um, and then trying to be able to detect that part of the model does something very different from the majority of the model with the interpretability tool.
I mean, would that necessarily look very different between, let's say, like two language models that have been trained on slightly different data sets? Their proportions of solving different tasks will look different. Does that mean that, your detection methods will also highlight these things as problems, or how does that work?
Yeah, well, again, I don't think a Mesa optimizer is necessarily bad. I think what's bad is an undetected Mesa optimizer that's influencing the output of the model in ways you don't know about and can't control. I think if you see the Mesa optimizer and understand it and know when it is and isn't being problematic in the outputs of the model, then it's fine to have a Mesa optimizer
I see.
and even expected. Yeah.
So you're
So
saying that
that's
if
kind
you
of
had like some printout sheet of the percentage goals that this model has and how much it cares about each of them or something like that, that would be sufficient, basically.
that's my thinking. Yeah.
Okay, okay, that
And I
makes some
haven't
sense.
seen other people mention that same point of view. So I maybe having some sort of off interpretation about the concept, but that's my interpretation. Yeah.
Yeah, I mean that certainly seems useful. I definitely don't want to push that in a different direction.
Yeah, it seems like the like Mesa optimization, like the strongest Mesa optimization story would be if like the frozen weights, or like if the like later part of the model is implementing something that can like optimize for any goal, and then the parts of the weights that you're optimizing for like just the math task are like just programming the goal of like solve this math problem, and then the rest of the network is just like implementing that goal or something. I feel like that's like the strongest story for this being a Mesa
Um,
optimizer, but I think it's like not. I'm not sure if you would like if that's just what you would get through the training process you described versus
right. I
like
don't think that's
having
what
the
it
early
is.
weights do most of the math work and then it just like passes through the rest of the network or something. So
Yeah.
yeah,
That is my main concern with this, which is why I was hoping that someone would have a way of making a way in mind of making this more clearly a Mesa optimizer, because I'm not sure that this toy example is accurate enough to count. But yeah. So do you have an idea for how to make it more like there was some sort of objective function that the math part was influencing?
Yeah. I wonder if there's like, I don't know, like I think producing a good example of language models doing meta optimization is like is an open research question requiring more progress or something. There's maybe some,
Yeah.
I don't know, like maybe if you had something where like you had a prompt where like the first part of the prompt is like some goal, and then the second part of the prompt is like a description of environment, like it's a maze or something, and then the first part is like
Mm.
here's the thing object in the maze you want to find. Like, I don't know, if like something like just if you just change the embedding of like the like goal part or something, like then maybe that's like sort of, and you could change that to like many different things, and then the like language model successfully like forms plans to do that. But I think that even that's a little also more just like a story of like being generally capable of like doing different goals and less clear about like what's happening internally. So yeah, I
Yeah.
agree. It's a difficult thing to like try to come up with.
Yeah. So I think what I will do is I will start with the simple but possibly so wrong that it's useless way, but at least have sort of a get through my workflow of making and testing, and then hopefully someone else will come up with a better way of making a toy mesa optimizer that I can then repeat that workflow on. That's that's
Yep.
kind of what I'm hoping. Yeah.
Yeah. And I think also detecting that a language model is like surprisingly good at some task. Like, oh, this language model is like much more good at this like subset of math than we like would have expected based on other stuff. Also seems like a good interpretability goal.
I agree with that.
Yeah.
Do you have any
Thank you.
plan for like when you feel like your tools will, like what suite of tools do you want to implement in order to start digging into the current cardboard cutouts you have now?
Yeah. So I think the like out of distribution detectors, the two papers I have in mind on that, and then just a general anomaly detector that can detect anomalies in weights or in activation states. So it's maybe the same architecture but trained on the two different things. So a couple of those couple of anomaly detectors, and then um, get get some more of the functionality that I have. Like I have the data saved for, but don't have it appearing yet in the tool because I haven't got the JavaScript working yet, actually working. And then I feel like, yeah, and so that's probably maybe another 6 to 8 weeks of work
Okay.
is what I'm imagining for that.
I mean, I'm kind of thinking that if your approach is really to just go straight at the problem, I would probably try an even more stepwise approach than what you're talking about and just implement one tool that I think probably has the highest leverage and see how far I can get with that, with whatever cardboard cutouts I immediately have, and then iterate on that for things that I learn in the process of things that I might need. Maybe it's anomaly detection or something else, but you know,
Cool. Yeah, that sounds like a good idea. So I should probably rethink my plans and have some more early attempts planned in there. So thank you.
sure. Any other questions,
Cool.
comments?
So good comments from three people, but a lot of you are quiet. So hopefully you will give me some anonymous comments uh, in
I also say
the
that's
feedback.
that's pretty normal for these meetings. I think allowing for some lurking is pretty standard. But
Yeah,
yeah,
yeah. That's why I was hoping that the anonymous feedback form would pull out
fair.
a little bit more thought from the shy people. Yeah.
Sure. Okay, great. Well, yeah, thanks for presenting. We really appreciate hearing what you've been up to. Yeah, please definitely visit the anonymous feedback form if you are so inclined, and maybe we'll call that the official meeting for today and hang up for as long as you like.
Cool. Thanks so much for coming.
Thanks a lot for presenting. Really appreciate it.
Yeah.